Good morning, ladies and gentlemen. This is section 2.5, the graph of y equals kx squared. So first of all, we're going to look at two different graphs and plug in the same values for x and look at our outputs and then graph those points on the same coordinate plane so we can notice the difference in the shapes. So let's start with y equals 4x squared. For each of these values of x, I'm going to plug them into x. And for negative 2, I get 4 times negative 2 squared. 4 times 4 is 16. For negative 1 squared, 4 times 1 is 4. For 0, 4 times 0 is 0. For 1, 4 times 1 is 4. And for 2, 4 times 4 is 16. So you can see how these points are a reflection of each other. If I plot those points, 0, 0 goes right here. Negative 1, 4 goes right here. 1, 4 goes right here. And I will always want to see those 3 points plotted on your XY graph correctly. Then negative 2, 16 is going to be way up here, right? And positive 2, 16 is going to be way up here somewhere. So when you graph these for homework, you need to show me at least 3 points to scale on your graph. Then we're going to go ahead and connect these points, and we see a pretty skinny parabola. Now let's go ahead and plug in values into 1/4 x squared. So let's change these to 1/4. And so over here, these will change to 1/4 times 4, to 1/4 times 1, to 1/4 times 0, to 1/4 times 1, to 1/4 times 4. So for this first point, 1/4 times 4 is 1. For the second point, 1/4 times 1 is 1/4. 1/4 times 0 is 0. 1/4 times 1 is 1/4. And 1/4 times 4 is 1. So when I come to my graph, I'm going to do this one in red. I still have 0, 0. That point is the same. But 1 and 1/4, these are pretty hard to draw perfectly to scale. That's approximately 1/4. So my second 2 points at 1 and 1, these are going to be my to scale points. So my exact points for this graph are 0, 0, negative 2, 1, positive 2, 1, and I still have 3 to-scale points that I know are perfect. But that's still going to allow me to connect the parabola through those points. Now I'd like you to look at the shapes of those points and think about how it changes from a coefficient of 4 to a coefficient of 1/4. And we'll talk about that tomorrow. Now we're going to try negative x squared and a negative 3x squared. And I'm going to start working a little faster. For my first graph here, I'm just going to plug in points when I have negative 2, negative 1, 0, 1, and 2. Here when I square it and multiply it by negative, I get negative 4, negative 1, 0, negative 1, and negative 4. And so when I graph those, I still get 0, 0 every single time, because I don't have anything added or subtracted, just shifted up or down. And then I have negative 2, negative 4, and this is an exact point, isn't it? So I'm actually going to be able to get 5 exact points on this one. When I connect these dots, I see this perfect parabola shape that is facing downward. All right? Now I'm going to look at negative 3x squared. When x is negative 2, negative 1, 0, 1, and 2. When I plug this in here, I'll get negative 4 times 3, which is negative 12. Here I get a negative 1 times 3, which is negative 3. Here I'll still get 0. Here I'll get negative 3, and here I'll get negative 12. Notice that these points are reflections of each other. So once I've found these, I've also found these. Because these points are reflections on either side of the y-axis. So when I go to plot these points, here I have 0, 0, negative 1, negative 3, positive 1, negative 3. And these are my 3 exact 2-scale points. The next ones go off my graph. And negative 2, negative 12 is going to be somewhere down here. And so I'll go ahead and graph these. And so for your homework, I want you to graph these 3 graphs on the same coordinate plane. And I want you to think about what the negative does, what the fraction does, and what the whole number does. What does this negative do to your graph? What does the fact that you're multiplying it by a whole number do? What does the fact that you're multiplying it by a fraction do? And I will see you tomorrow.